So, hello again, folks. Hope we're all doing okay, enjoying your work as much as I am. So, today's recorded PowerPoint is all about series and parallel circuits, which I know I keep saying this in all of these videos that you've met this in first and second year, but at Nat 5 you obviously need to have a lot more input about it. So, last week we introduced the topic of what resistance was and the Ohm's law, which is V equals IR, is one version of it. That's the way it will appear in your formula sheet. And using Ohm's law, you did a whole lot of questions last week, or you should have done a whole lot of questions last week about how to calculate the resistance of a resistor or some component when it's part of a circuit. I forgot to mention last week, so that's why I'm doing it just now, that there is a device called an ohm meter, which can be used to measure the resistance of a resistor directly. So you don't have to have it as part of a circuit where you work out the voltage or you measure the voltage and the current through the component and then use Ohm's law to calculate the resistance. If you want to just measure the resistance of a component or a thing directly, then you just connect it straight across this device here, this thing here called an ohm meter. Now, but it can only be used to connect straight across the component. In this case, we've got a resistor. So this ohm meter, when you connect it to that resistor, would measure the resistance of that resistor directly. And there's no other part of the circuit. There is no battery or anything else in the circuit. It's just you connect the ohm meter straight across like that, and that will give you the resistance. So that's a device called an ohm meter, and that's the symbol, which I think was included in the symbols that you had last week. So again, series and parallel circuits. So in Nat 5 physics, you're going to be dealing with both of these types of circuit, and the more complicated ones, the extension ones, are going to be where you've got a combination of the two types of circuit. They're the most difficult to deal with. So there'll be the extension work. So here we've got a simple series circuit. And the definition of a series circuit is there's only one path for the electric current to flow from the negative terminal. So this is the negative terminal of the cell or power supply or battery, whatever. And the electrons are going to flow round the circuit here through the two lamps in this case, or any other components that were there, and then back to the positive terminal of the cell. And we've already dealt with electric fields and voltage, etc., potential difference. So that makes sense. So there's only one path, and so that's called a series circuit. In a parallel circuit, a bit more complicated, there are two or more paths around the circuit. So, and there's at least one point in the circuit where you have a choice of path. So if you imagine here's the electrons leaving the negative terminal here, they travel around the circuit, and this wee black dot represents a junction. And so the electrons, some of the electrons will go through that lamp, and some of the electrons will pass through that lamp and go back. So we have got, in this case, we've got two paths or two circuits. And because of this, parallel circuits have got certain things that they do that series circuits don't, etc. And hopefully we're going to look at that throughout the next wee while. So in a bit more detail, so this looks super complicated, it's not really. What we've got is a series circuit. Just ignore, so these two, A1 and A2 are ammeters, V1, V2, V3 and V supply are voltmeters. So it makes the circuit look really, really complicated, but it's really just to kind of highlight the properties of a series circuit. So the two ammeters and the voltmeters are connected in the circuit. Remember, ammeters are connected in series, break into the circuit, voltmeters are connected across or in parallel to the circuit. In this case, if you imagine the current or electrons leaving the negative terminal of the cell, all of the electrons, because there's only one path, all of the electrons will travel through that ammeter, they'll all travel through that resistor, that resistor, that resistor, and they'll all travel through that ammeter as well. So here's one of the first rules that you need to be aware of, that in a series circuit, the current is the same at all points in the circuit. Anywhere in the circuit, the current will be the same. So in this case, the readings on that ammeter and the reading on that ammeter will be exactly the same. And in fact, the ammeter can be anywhere. It can be right next to the cell or in between the resistors, still going to be the same. But the voltage from the battery or the power supply or the cell will split up between the components. We kind of mentioned that in the last couple of weeks, I think, and such that the rule to remember is that the supply voltage will equal that voltage plus that voltage plus that voltage. Probably I should be saying potential difference in this case. So the potential difference across that resistor plus the potential difference across that plus that is going to add up to supply voltage. And I did sneak in a couple of wee questions about that in the last few weeks assignments. So in a parallel circuit, here is a parallel circuit. I know it looks complicated again because we've got 1, 2, 3, 4 voltmeters and we've got 5 ammeters, but if you ignore them, that's basically a reasonably simple parallel circuit. We've got the junctions there, so we've got, in this case, the current would leave the cell here, it'll go round the circuit and split up here. But we'll look at the voltage first of all, or potential difference, which is maybe where this explains this in more detail. So if you think about this power supply has got a potential difference, so that terminal is at a certain potential, that terminal is at a certain potential, so there's a potential difference. Now these 2 points here are, if you just think about it, connected by a wire to these 2 points here, which is connected to these 2 points here. So the potential difference across here will be the same as the potential difference across here and across there and across there. So these voltmeters here and that voltmeter are all going to read the same value or the same potential difference because they're all connected to the same 2 points like that. So in a parallel circuit, the voltage is the same across all the components. And in this case, it's going to be the same as the supply voltage. So I started talking about the current. So the current leaving the cell has only got one path at this point, but then it's going to come to this junction and some of the current will go through there. We'll call that one I1. And then it comes to this junction and some of it will go through there. That will be I2. And some of it will go through this junction, this resistor, and that will be I3. And the rule for a parallel circuit is because the current is splitting up at this point, the supply current will equal I1 plus I2 plus I3. The rules, I think it's called Kirchhoff's rules, are basically the current going into a junction has to be the same as the current leaving the junction. So for example, if the total current here was 3 amps, say, then between these 2 wires, there would have to be 3 amps. So that might be, there'd be 1 amp through there, and then there would be 2 amps coming to this point, and then the same thing, 2 amps going into that junction, you'd need to have 2 amps leaving it. Okay, so that's everything for this PowerPoint. Just put a kind of a summary up as the last slide here to kind of highlight what happens in a series circuit and what the rules are. Basically, the current is the same everywhere and the voltage splits up, but in a parallel circuit, the current splits up and the voltage is the same. So the rules are the exact opposite from a series circuit to a parallel circuit. And if you can memorize these rules and use these rules, then it will stand you in good stead. So as usual, there'll be some questions for you to complete. And then on the Thursday, there'll be a quiz on this stuff as well. I think it's going to be 2 parts again because there's more we can do about series and parallel. We can do series and parallel resistors, which I think is going to be the next topic. So good luck again. Remember to ask any questions you need to. You can do it by email or on Teams, whatever. And see you next time.